Right, for particle motion, we know if a particle is moving left or right, if the particle speed or velocity is negative, or right if the velocity is positive. I know it changes directions when v equals 0 and v changes signs. I can tell the speed is increasing if a of t and v of t are the same sign, and decreasing if a of t and v of t are opposite signs. To find velocity given the position, velocity is just x prime derivative, and acceleration is just the derivative of the velocity, or you can think of it as a second derivative of position. To find average velocity, that would be average rate of change, like this. Now we're finding the average rate of change of the position to get the average velocity, so then you just plug in your position. To find average acceleration, that's average rate of change of the velocity. Because remember, when you divide position over time, you're finding the rate of the position, which is average velocity, and the average rate of the velocity, which is acceleration. When finding dy dx, the derivative of x is just 1, right? You can think of it as dx over dx, which just cancels out, and the derivative of y is dy over dx. And don't forget to use your product, chain, quotient, etc. And then for related rates problems, we do our derivative with respect to time. So if I have x, derivative of that is not 1, it's dx dt. Alright, so cosine of 0, think of your unit circle. Cosine of 0 is 1. Cosine pi is negative 1. Cosine pi over 2 is 0. 3 pi over 2, 0. Sine of 0, 0. Sine of pi, 0. Sine at pi over 2, that's 1. And sine at 3 pi over 2, that's a negative 1. Cosine of 2 pi, so that's going around the entire thing, back at 0. 3 pi, that's back at pi. Sine of 2 pi, back at 0. And 3 pi, sine is 0 here. Natural log of 1 is just 0, we need to know that. And natural log of e. So think about, remember, this is, natural log is log base e of something. So that means e to the what power gives me 1. E to the 0 gives me 1. Now here, this is saying e to what power gives me e, well, the power of 1. So natural log of e, remember, natural log and e kind of cancel out. You're just left with 1. Finding dy dx when x equals 1, so take derivative, product rule here. I'm going to move these over, so I have 2x plus y equals dy dx minus x dy dx. I'm going to factor out a dy dx, and I'll be left with 1 minus x, and I'll divide that over. Now I'm trying to plug in when x equals negative 1, so dy dx equals 2 times negative 1 plus and 1 minus negative 1. Now I need to know what my y is, so in order to find the y value that goes with x, see how you just take that and plug it into our original, so negative 1 squared plus negative 1y minus y plus 1. Negative 1 squared is 1, 1 plus 1 is 2, negative y minus negative y is negative 2y. Y equals 1. And then we've got negative 2 plus 1 over, this becomes 1 plus 1, so that's 2. Negative 2 plus 1 is negative 1, so negative 1/2. Here, I'm going to use my chain rule, so I've got 3x plus y squared, derivative of the inside would be 1 plus dy dx. This would just be 3x squared, don't need it, plus 3y squared dy dx. I'm going to distribute this term, so this is 3x plus y squared times 1 plus 3x plus y squared dy dx equals 3x squared plus 3y squared dy dx. I'm going to switch these, so this becomes 3x plus y squared minus 3x squared equals negative 3x plus y squared plus 3y squared, and both of these have a dy dx, which is why I can then just divide this entire term over, plus 3y squared, and that's what dy dx is. And now I just need to plug in x equals negative 1, y equals 1. So I've got 3, negative 1 plus 1 squared minus 3, negative 1 squared over negative 3 times negative 1 plus 1 squared plus 3, 1 squared. Negative 1 plus 1 is 0, 0 squared is 0, 3 times 0 is 0. So these both just go away because they're multiplied by 0. This becomes just negative 3 over 3, which is negative 1. Alright, solving for dy dx and trying to simplify. So here we're going to use chain rule. Derivative of tangent is secant squared. Leave the inside alone. Then multiply by derivative of the inside. Derivative of x squared is 2x. Derivative of pi. Pi is a number. It is 3.1415, blah, blah, blah. Derivative of that is just 0. Don't treat this like a variable. It's a number. So then distribute secant squared of x plus y plus secant squared of x plus y dy dx equals 2x. Subtract this over, and then just divide. So we've got 2x minus secant squared x plus y over secant squared x plus y. Here, chain rule and product, so derivative of the outside, so derivative of natural log is 1 over, leave the inside alone, so it's 1 over x times y, times derivative of the inside, so that would be 1y plus x dy dx equals 2x. Easiest way to solve this, I find, is just multiply the xy up, so multiply xy on both sides, now it's just y plus x dy dx equals 2, x times x just becomes x squared, so 2x squared y, subtract y over, divide by x, and there's your derivative. Let's see, derivative of e to the something is just e to the something, but then you need to multiply by derivative of the inside. Derivative of the inside would be product rule with x and y, so 1y plus x dy dx, plus derivative of x is 1, derivative of y is dy dx. Distribute, so this is y e to the xy plus x e to the xy dy dx plus 1 equals dy dx. Let's move this term over. So we've got y e to the xy plus 1 equals dy dx minus x e to the xy dy dx. Factor out a dy dx, you'll be left with 1 minus x e to the xy, and I'm going to divide that over. 1 minus x e to the xy, and that will give me my dy dx. Here, product rule with the negative x times y, so I've got negative 1y plus negative x dy dx equals dy dx plus 2y dy dx. Get this term over, so I've got negative y equals dy dx plus 2y dy dx plus x dy dx. Factor out a dy dx, and that will be a 1 plus 2y plus x. Here, I'm finding the second derivative. See how I've already been given the first derivative? So the second derivative, just need to take it once because I already have the first derivative, would be, gotta use quotient rule, low d high minus high d low. Underneath the low squared goes. So this is just y minus x dy dx. Remember we just got we already know it. So this is just x over y. So then this is y minus x squared over y squared. I do not like to have a fraction and a fraction. So in order to get rid of this y right here, if I just multiply top and bottom by y squared times y is y cubed on the bottom now. Y times y cancels out. This is just minus x squared. And don't forget this guy gets multiplied by y, so it's y squared. Second derivative is y squared minus x squared over y cubed. Right, radius r of a sphere is increasing at a uniform rate of 2, so that is the rate of the radius, dr dt is 2. At the instant when the volume is, so v is 36 pi, what is the rate of increase in the surface area? So looking for ds dt. So I'm going to take derivative of ds dt right here, so that will be 8 pi r dr dt. So that's 8 pi, need to find r, dr dt is just 2. So now I need to find dr dt, but see how I was given the volume? So volume is 4 thirds pi r cubed 36 pi equals 4/3 pi r cubed. Solving for r, pi's cancel. Multiply the 3 up and divide the 4 over. 36 divided by 4 is 9. 9 times 3 is 27. Take the cube root, and r is 3. Right? 3 times, yeah. And then now we just plug in. This is 6. 6 times 8 is 48. So your answer is 48 pi for the STT. Finding dy dx for this is 2x, 2y dy dx equals derivative using product rule, so 2y plus 2x dy dx. Let's switch these. So I've got 2x minus 2y equals 2x dy dx minus 2y dy dx. Factor this out, that will be, this is 2x minus 2y, which actually cancels out, and you just get 1. Weird. Here, finding dy dx, derivative of tangent is secant squared, leave the inside alone, times derivative of the inside, which is 1y plus x dy dx, equals 1. Distribute. There's a y with this one, there's an x, and a dy dx with this one. Subtract. I've got y minus. Now divide. So I have 1 minus, that's enough squared. 1 minus y secant squared. 1 minus y secant squared over x secant squared. And then you'll notice that actually none of my answer choices look like that. Now I know I did it right, so I'm going to have to rearrange this. So this is where knowing what the definition of secant is super important. Secant is just the 1 over of cosine. Alright, so this one, it's talking about secant squared, so secant squared of xy is just 1 over cosine squared of xy. So I'm going to rewrite it in the way that it is. Now here I'm going to do just like I was doing earlier. I have a denominator, so the easiest thing to do is literally just multiply top and bottom by that denominator. See how this will cross off and it'll just be minus y. See how this will cross off, it'll just be x, and then this gets multiplied, so it's cosine squared. And hopefully that's an extra choice. Yep, perfect, E. Particle moves so that this is its position. When is the particle at rest? Particles rest when the velocity equals 0. This is position, so velocity is 3t squared minus 6t plus minus 9. Derivative 1 is 0, set that equal to 0. Factor out of 3, that's t squared minus 2t minus 3. Keep factoring. I want to multiply to negative 3 and add to negative 2, so that would be negative 3 and positive 1. So t minus 3 and t plus 1. So then the t values are at 3 and negative 1. Negative 1 is obviously not going to be a time because it's t greater than 0, so it's just at t equals 3. So 3 only. When does it move to the right and left? So 3, starting at 0, going onward. If you plug in 2, that would be a negative, everything else positive. So then here it is moving to the right, t greater than 3, and moving to the left between 0 and 3 seconds. Circular puddle is growing, circumference is increasing at a rate, so that would be the derivative of the circumference, dc dt. When the circumference is, so c equals 4 pi, what is the dA dt? So I'm looking for the area, or rate of the area, so dA dt equals 2 pi r dr dt. So I need to find r. I'm going to use circumference to find r. So circumference is 2 pi r, 4 pi is 2 pi r equals 2. And then to find dr dt, because now I have r, now I need to find dr dt, but see how it gave me dc dt? So derivative of c would be dc dt is 2 pi times dr dt. dc dt is 6 pi equals 2 pi dr dt. So then dr dt is equal to 3. And now this is 6 times 2, so area rate is 12 pi. dA dt is 12 pi. Particle moves so that this is its position, one is at rest, so set velocity equal to 0. First you need to find velocity. This is going to be product rule, so v of t. If you need to do it off to the side, u is t, u prime would just be 1, v is e to the negative 2t. V prime, derivative of e to the something is e to the something, but then times derivative of the inside would be negative 2. So then we've got our u prime v plus u v prime. U prime is 1, v is e to the negative 2t, plus u v prime is e to the negative 2t times negative 2. I'm going to set this equal to 0, so I'm going to factor out, see how they have a common factor of e to the negative 2t. That's going to leave me with the factor of 1, and then minus 2t. So obviously setting this one equal to 0, 1 minus 2t equals 0, 1 equals 2t, t equals 1/2. So the value of 1/2 would make this 0. And then if you think about e to the negative 2t, there's no t value that you can plug in that would make this 0. Because there's e to something equals 0, you can never get that, right? Even if you put in 0 here, it becomes 1. So this one, there's no value that makes it 0, so I'm only worried about this, so then it's just at 1/2 only. Radius is increasing at the time when the volume and the radius are increasing at the same numerical rate. So the volume rate and the radius rate are the same, so dv dt is the same as dr dt. What is the radius? Looking for r. Okay, so we're going to take derivative of the volume, so dv dt equals, multiply the 3, that cancels out, so it's just 4 pi r squared dr dt. Now I'm going to take dv dt and replace it with dr dt, so dr dt equals 4 pi r squared dr dt. So then we're going to divide to get r by itself, 4 pi dr dt. That cancels, but there's still a factor of 1, so I have 1 over 4 pi equals r squared, because I've divided these over, and then just take the square root. This is 1 over the square root of 4 pi. Which you can say square root of 4 is 2, but then see how the root, pi is still in the root, so that's the same as 1 over 2 root pi. Either one is the same. Wow, I did a lot of when is it at rest. V equals 0. Again, I gave you position, so you have to find the velocity by taking derivative. Derivative of sine is cosine. Leave the inside alone, but then multiply derivative of the inside. Derivative of 2 pi t is just 2 pi. Plus, this one is 2 pi t, so 2 pi is a coefficient, so derivative of 2 pi t is just 2 pi. Set this equal to 0. 2 pi cosine of 2 pi t plus 2 pi. Subtract over. Divide by 2 pi, so this is just negative 1 equals cosine of 2 pi t. So think about where is your cosine value negative 1, right here. So that's at pi. So if you want to have pi, then your t value needs to be 1/2, because then 2 times pi times 1/2 would cancel out and give you at pi, which is what you want to get the negative 1. So then t equals negative 1. No, t equals 1/2. Ignore me. Alright, here's my position. What is the average velocity? So average velocity will be x of 2 minus x of 0 over 2 minus 0. So that's over 2. Now I need to find x of 2. That's 4 times 4 minus 2. 16 minus 2 is 14. And then x of 0, plug in 0, it's just negative 2. So that's minus negative 2, which adds is 16 over 2, which is 8. Position is given by that. What is the acceleration when the velocity is first equal to 0? So what you're going to do is find v equals 0. What time is that? And then find a of that time. So let's find our velocity equation. So velocity is derivative of sine is cosine. Derivative of cosine is negative sine. So negative negative would become plus sine. Set that equal to 0. Cosine t equals negative sine t. Think about when your x and y, your cosine and your sine, are the same value, just opposite signs. That's going to be in this quadrant at the pi over 4 when they're root 2 over 2 and negative root, or it's negative root 2 over 2 and root 2 over 2. So that is pi over 4, 2 pi over 4, 3 pi over 4. So this is t is 3 pi over 4. Again, I chose the angle, or the time, in this case is the angle, at which cosine and sine are the same value, just opposite sides. So we know it would be in this quadrant or this quadrant.